everyone. I'm Stephanie Regannon, Executive Director of Innovation Partnerships at the Danforth Plant Science Center in St. Louis. Welcome to another Virtual Conversations event. We are thrilled to have a remarkable guest with us tonight, Dr. Pat Brown, founder and CEO of Impossible Foods. It is my honor to moderate what I'm sure will be a fascinating and insightful discussion. Before we begin, I would like to thank everyone on the Friends Committee and the Conversations Committee for their tireless dedication to organizing these programs. Thank you as well to our media sponsors, St. Louis Public Radio and HEC Media. After the event, you will be able to watch the recording at hecmedia.org. If you'd like to ask a question during tonight's discussion, just click on the Q&A button at the bottom of your Zoom window to submit. Questions will be addressed as time permits. Now, without further ado, it is my pleasure to welcome Dr. Pat Brown.
Hey, thanks, Stephanie, and thanks for the invitation and the opportunity to be here. I want to start by just giving a brief introduction as to how I find myself in this weird role. I was, for most of my adult life, I was a professor at Stanford doing basic research on a whole variety of things, but basically my job was, maybe this is the way that people at Danforth think of their jobs too. It was literally just to follow my curiosity wherever it took me and try to discover things and invent things and teach students how to do the same, basically. And it was the best job I could ever have imagined. And I never imagined that I would be doing something much different from it. And yet here I am. I found myself in the position 10 years ago where I was founding a food company. And I had no business experience. I was basically, not particularly qualified for the job by any normal standards. And I didn't even have that much interest in food. Food is great, it's fine. I'm perfectly happy to eat it, especially if it's delicious, but I don't spend any time thinking about it. And I've literally never taken a picture of a plate of food in my entire life. And I don't intend to particularly. So it's just like, I'm not a natural for this job, except for one thing, which is the most important thing. And that is that, I decided to do it. And just as a comment there, I feel like, there's something good. It's actually kind of relevant to talking to this group, because if you're a complete outsider, like the last person who someone would ask to do this, and don't have the usual qualifications, I think actually that's an advantage in many respects, because among other things, I wasn't really, imbued with the culture of food and agriculture and so forth, and I didn't come with a set of assumptions about what it should be all about and so forth. But anyway, let me just tell you how I wound up in this situation. So I'm going to share my screen, get started, and so yeah, why am I here? As I said, about 11 years ago is sort of when I realized that I was going to do this. And I'll tell you what it was that motivated me to do this, which is, as far as I'm concerned, probably the most important thing that I hope anyone can take away from this. And the answer, oops, I'm sorry, I'm messing up with my slides here, is that I realized this fact that the use of animals as a food technology is by a huge margin the greatest threat to our planet today, and arguably the greatest threat that humans have ever faced. And that will probably come as kind of like, well, what a ridiculous, wacky thing to say to many of you. So let me just take you through a couple of reasons why I came to this conclusion. So it doesn't get talked about nearly as much as climate change, but I think this is probably very plausibly a greater threat to the future of our species, to the future of life on planet Earth than climate change. And that is that we're in the late stages, I mean, in the really late stages of a continuing, ongoing, catastrophic collapse of global biodiversity. And this is just one measure of it, but I think it sort of vividly illustrates the situation. There's been a study going on now for about more than 50 years that's being carried out by a consortium of scientists around the world. It's sort of largely organized and funded by the World Wildlife Fund and the Zoological Society of London. And what these folks have been doing is they've selected a set of more than 4,000 wild animal species that were chosen to be kind of a representative sample of animal biodiversity globally. And they've been tracking the populations as a way of literally sort of a sampling method for measuring the health of global ecosystems. And what they've reported last year, and it's a continuing report, is that the total populations of wild mammals, wild birds, wild reptiles, wild amphibians, wild fish, across all these 4,000 representative species are less than a third what they were 50 years ago, okay? That is, if that doesn't scare the pants off of you, you're not paying attention. Because it's not just that it's a shame that, you know, these animals that we think of as, you know, just part of nature and part of the kind of why we're so lucky to have planet Earth are disappearing so fast. I mean, again, this is just over 50 years. But these species are critical components of ecosystems whose health depends on the whole kind of web of life, the whole set, the whole diverse set of animals and plants and so forth in these ecosystems. And we've taken these kind of essential components of that ecosystem and just devastated them, okay? And I think that the cascading effect of that on the animal wildlife, we haven't really begun to see even, you know, much of the effects on plant biodiversity because they take a while. You're talking about animals that their function in the ecosystem. Some of their important functions are pollinating and distributing seeds of the major plant species there, turning over dead biomasses, keeping, you know, insects under control and all this sort of stuff. And when those things go out of whack, you don't see the full impact right away. But when those trees die and nothing replaces them, which by the way is a phenotype of a lot of the state of California, where there's an interesting demographic thing about the oak trees that all these beautiful gnarly oak trees that you see on the California hills pretty much are all like 100 years old or more. And the reason is very simple. As soon as people started having cows on the land, no acorn was ever going to grow into a mature oak tree again because they get munched on before they grow up. Anyway, the point is that you don't feel the full effect until those oak trees die and now you got nothing. So the point is, this is ongoing. And why does it have anything to do with impossible foods and so forth? Well, the basic answer is it's almost entirely due to our use of animals in the food system, using animals as a food technology that turns, you know, plant biomass into animal tissue or milk and that we like for food. So for fish, this big component here, this is a chart from the publication by the World Wildlife Fund that attempts to sort of quantitate, and obviously it's a, you know, just an estimate, the impact of various contributors to this biodiversity collapse. Biggest one is this blue curve on the right. It's exploitation. That's basically hunting and fishing, direct exploitation. And that's mostly overfishing, which is for all practical purposes the cause of the global collapse in fish populations, which are 70% less than they were 50 years ago in both freshwater fish and marine species. Then the red and green sectors here represent habitat destruction and degradation. And that is, again, almost entirely due to the use of animals as food technologies, I'll get to in a second. The other sectors, climate change, invasive species, pollution, and so forth, disease, actually, the use of animals, animal agriculture is a very significant contributor to all those, as I'll get to in a moment. So when I say the use of animals as food technology is overwhelmingly responsible for a global collapse in biodiversity, it's unquestionably true. Although you can ask me questions about and challenge on me if you want it later. This is just to kind of emphasize that point. So today there's 1.7 billion cows living on Earth. Those cows, if you were to weigh them all and sum up their weights, and then weigh all the remaining wild terrestrial vertebrates, birds, mammals, reptiles, and amphibians, and compare the two, the cows outweigh every remaining wild mammal, bird, reptile, and amphibian by more than a factor of 10, okay? And what makes it even more ridiculous and like, not that the people who are doing it were crazy or stupid or something like that, but when you step back and look at it, just totally whack, is that those cows, which are by biomass overwhelmingly the most dominant species on Earth, and have basically outcompeted all the wild animals, they account for less than 12% of the protein in the global human diet, okay? So for this, we've replaced nature with cows. And by the way, I'll just add, the pigs living on Earth today that are being raised for human consumption weigh 150% as much as all the remaining wild terrestrial vertebrates. The sheep and goats, 125%. And the birds being raised for food on Earth outweigh all the remaining wild birds by more than a factor of 3. So it's just across the board, we're replacing nature with the food animals we consume. And getting back to the cause, when you talk about habitat destruction and degradation, here's the critical thing, okay? Animal agriculture is the overwhelming majority of the land footprint of humanity. Every city on Earth with a population of more than 100,000 can fit on less than 1% of Earth's land area. And every human-built structure, house, highway, parking lot, factory, whatever, fits on about 2% of Earth's surface. And animal agriculture occupies about 45% of Earth's ice-free land surface. This is according to a group of livestock ecologists at the International Livestock Research Institute that have published a number of papers on this. Okay, so you get the idea that if there is land that has been touched by humanity, it's almost guaranteed to be used for animal agriculture. And this problem is continuing because the demand for meat and dairy foods is growing faster than the human population, okay? And you need land to support the system. And Earth is not getting any bigger. So the only way that you can expand the system is by encroaching on previously intact ecosystems, and that's what's happening in the Amazon. So 95% of the deforestation in the Amazon is basically expanding land to support cattle, and the same is true in tropical forests in Africa and elsewhere in the world, where a lot of the same stuff is going on, but you just don't hear about it as much. And so, as I like to say, that smoke you see rising from the Amazon is the secondhand smoke from your burger. This is a slide that I like to use as sort of a microcosm of the global problem, but also the opportunity that the reason I'm doing this is not that I'm bummed out. I mean, I am, but by the impact of the system. It's that there's a real opportunity to fix it, okay? And this is to illustrate that. So this is Point Reyes, which is a peninsula north of San Francisco that is a beautiful coastal landscape. About half of Point Reyes is protected, effectively protected wilderness. And that's what you're seeing here. This is a trail to a lagoon that my lovely wife is walking down here. And what you're seeing basically is sort of typical California coastal ecosystem. It's very biodiverse. You can't see or hear the wildlife there, but take my word for it. And it holds a lot of biomass, okay? Well, the other half of Point Reyes is farms, it's beef and dairy farms, okay? So on the left, you see a barbed wire fence, and let's peek over that. And this is the other half of Point Reyes. And you can see a difference there, I hope. That, and this is, by the way, a farm that bills itself as a sustainable, organic, grass-fed beef farm, okay? That's literally what they call themselves. In fact, they even say they practice renewable agriculture. So anyway, this is what, it looks like. And you can see that there's vastly less biomass on that land, okay? There's not all that plant cover. There's vastly less biodiversity. It's basically just cows, maybe a few sparrows. Okay, that's a microcosm of the planet. And if you actually do the analysis and look at how it scales planet-wise, the difference in biomass on the native ecosystem compared to the land that's being used raising animals for food globally is the equivalent of about 16 to 18 years. And this has been well studied, and there are a couple of publications, one this year, one last year, and some dating back a decade, that have counted this, and this is quite a consensus number. It's the equivalent of 16 to 18 years worth of total greenhouse gas emissions at the current rate. The current rate is depressed temporarily by COVID, but it's bouncing right back up. Okay, well, that is interesting because that's an opportunity, because what it means is that if we can find a way to eliminate the need to cover the planet with cows, okay, it would enable the restoration of these healthy ecosystems that not only could reverse the collapse of global biodiversity, but pull back out of the air the carbon that was emitted when the original biomass was effectively, excavated to prepared for raising cattle and so forth. Okay. And that's what Impossible Foods was found to do. What we're trying to do is, if we can eliminate the need, if we can eliminate the economic incentive for covering the planet with cows and or crops to feed pigs and chickens and so forth, we can unlock this huge opportunity. And I recently published a paper with a colleague of mine at Berkeley that actually calculated the magnitude of this effect for the first time. Really, what would be the climate opportunity of replacing this industry? So people have calculated, like, what are the ongoing emissions from the industry, but they have not calculated the opportunity cost. What would be possible if we weren't doing this? So when you do calculate that, and you can look it up, it's on bioRxiv, which is open access. Anyone can download the paper and scrutinize and criticize our analysis if you want. The opportunity is humongous. It's so far greater than anything that anyone had previously imagined. But I think that the data are absolutely clear. We could, by replacing livestock in the global food system over the next 15 years, which is what Impossible Foods is trying to do a couple of things. We would set ourselves on a different trajectory for atmospheric greenhouse gases that over the course of the rest of the century would contribute half as much to global warming. In other words, we would offset more than half the total climate effect of human greenhouse gas emissions, offset more than half the human impact on climate, even if there were no reductions in fossil fuel emissions. So if nothing else changed and we just did this, we reduce total heating of the planet by half through the rest of the century. Second thing, which is really important, is because the benefits happen fast, and there's two main drivers of them. One is the recovery of biomass on this vast amount of land where it's currently depressed by animal agriculture. The other is there are two major greenhouse gases that don't get the attention they deserve. One is methane, one is nitrous oxide. The largest anthropogenic source of both of those is animal agriculture. And you can calculate the amount of those gases currently in the atmosphere that are attributed to and maintained by animal agriculture. And we've done that, and you can just derive it very quickly from publicly available data from IPCC and others that track greenhouse gases. The magical thing about methane and nitrous oxide, though, is that unlike carbon dioxide, when you emit carbon dioxide, the only way you ever get it back is by photosynthesis. You have to turn it back into biomass, which is the green half of this chart here. The purple and red sectors represent the fact that methane and nitrous oxide spontaneously decay. So when you stop emitting them, unlike carbon dioxide, where it's going to be there forever, you turn on decay of methane and nitrous oxide, and those are net negative greenhouse gas emissions. So biomass accumulation is net negative greenhouse gas emissions. Methane decay, nitrous oxide decay, net negative greenhouse gas emissions. And that's why this is such a powerful effect. And they also happen fast. And this represents sort of the kinetics of it. As a result, you buy yourself, starting in, if we do this over the next 15 years gradually, starting in just before 2030, you buy yourself a 30-year pause, a 30-year period where the net greenhouse gas emissions are zero. And that is a huge opportunity for us to put in place other things to reduce ongoing greenhouse gas emissions. And just a point that I think is worth making is that beef and milk production, cattle basically, represent more than 80% of the opportunity cost of animal agriculture. So if we did nothing but replace cattle in the food system, we get basically 80% of this benefit. Just beef alone, forget about dairy, would offset, it would accomplish half of the effect, so offset 25% of total greenhouse gas emissions through the end of the century. And I'm just trying to explain for non-scientists what radiative forcing is. It's basically the heat delivered to the atmosphere by virtue of the greenhouse gases preventing radiative heat loss. So you can think of it as, this y-axis is kind of like, how hot is this oven that we're putting the plant in? And then the x-axis is time. And so that matters too, because the longer you have the oven on, the more heat gets transferred to the planet. I have just for the sake of illustration, to really understand the magnitude of the heat transfer to Earth that we can avoid by succeeding in our mission. And it's just simple thermodynamics, so you can do the calculation. The amount of heat transfer we avoid is enough heat to melt a 15-foot thick ice sheet covering the entire surface of the planet, okay? All the land and water, 15 feet of ice on it. The amount of heat we save by eliminating animal agriculture over the next 15 years is enough to melt that 15-foot ice sheet, or put another way, it's enough to melt a 100-mile diameter ice ball, which this is illustrated relative to San Francisco Bay, so that's a pretty big chunk of ice anyway. Or probably 100, bazillion ice cubes if you'd rather. this is just another way of doing it to kind of put it in comparison to things that people more commonly think of as greenhouse gas problems. You could compare the climate impact of consuming a pound of beef today on the 2050 climate, okay? And you might be asking why the 2050 climate. It has to do with the fact that these effects are time dependent. It's not just how hot is the oven, it's how long it's on and stuff like that. But anyway, those can be details. But if you consume a pound of beef today, you have a climate impact by 2050 that's equivalent to driving from St. Louis to Chicago and back, okay, in a typical American car, 22 miles per gallon. I don't want to belabor this, but I think everybody knows that animal agriculture is the biggest consumer and polluter of water of any technology or industry in the world. There's just, and this is an increasing problem because more and more of the world is under severe water stress, including California. But there's an interesting recent paper that was talking about just in the US situation that did a very detailed inventory of where the water goes. And they reported, for example, that 55% of all the water that flows out of the Colorado River Basin is used to irrigate crops to feed cattle, okay? So the Colorado River used to flow into the Gulf of California. That's long since hasn't happened, but basically more than half of all that water, that huge river flow, is just producing basically mainly beef. Okay, so now enough whining about the problem. When I became aware of this, I just felt like, okay, I got to do something about it. And what I realized was that, like, a lot of people were sort of aware of it, even the climate scientists. They didn't realize how big the impact was, but they knew it was a problem. But nobody was talking about it, okay? It was basically kind of off limits to talk about as a potential climate solution or a problem. And I don't fully understand it, except that I think that there's this pervasive assumption that, you know, the global food system was established sometime in the ancient past, and it's just going to be what it's going to be, and it's not something we can change. It's like, at this point, people think of it as, oh, it's part of nature or something like that. So it's just like people don't even spend time thinking about it. And I know I was at the Paris climate talks, and literally nobody was talking about it. And all of those ecologists and climate scientists and so forth went out and had a steak for dinner. So, and that tells you you're not going to solve this problem by educating people, because these are the most educated people in the world about climate and environment and so forth. And it's not enough to motivate them to change their diets. So that was really an important insight, and obvious that you're not going to solve the problem by trying to get people to change their diets, either by educating them or bullying them or nagging them or regulating them, anything like that. Just forget about it. That's not going to work. But there's a much better and faster way to solve the problem. And that's why I found Impossible Foods, which is to recognize that the problem is not the foods that people choose to eat, their food preference. That's not the problem. The problem is we're making those foods the wrong way. It's not a problem that people love meat and dairy food. It's that we're still using the same prehistoric technology that we've used, you know, throughout history to produce those foods, and we don't need to anymore, okay? It was, you know, it just happened that cows could be domesticated, and so, all right, you know, seemed like a good idea at the time, doesn't seem like such a good idea now, and we can figure out better ways of producing foods that deliver all the things that consumers value from those foods with a fraction of the environmental impact. So that's what I'm going to talk about now. And don't worry, I'm not going to go on forever because I'm actually almost done. I mainly want to talk about the problem we're solving. So I found Impossible with a simple mission, and this is still our mission. It's to reverse the collapse of global biodiversity and avert climate catastrophe by completely replacing the use of animals as a food technology by 2035. That's our goal. So, and the strategy is simple. We're not going to impose our will on anyone, okay? But we see the opportunity as it should be possible to do a better job than the cow and the pig and the chicken at make these very specific foods, beef and pork and chicken and so forth, that deliver all the things consumers value from those food. The specific sensory pleasures, the taste, the aroma, the texture, mouthfeel, all of that stuff, the nutritional value, the convenience, the affordability, and to do that without using animals, okay? And that was the thesis. And then if we could do that, we just let consumers choose. And if history is any guide, when better technology comes along and does a better job of serving the needs of consumers than the incumbent technology, it flips quickly. So that was the theory. I just want to make a point. A lot of people think of Impossible Foods as a food company, and we are a food company. Our food is the vehicle by which we achieve our mission. But really, the way that we operate and the way we think of ourselves is we're a technology platform company. You know, it's not like we're not solving the problem by making meatballs. We're solving the problem by figuring out how to replace the cow as a system for making beef. And then you can make a bunch of food products from it if you want, and so forth. This is a technology problem, and we are a technology platform company that just looks from the outside like a food company. So when I founded the company like about 10 years ago, I did what probably the people at the Danforth Center would have done, which is I felt like this is a scientific problem. I did not know at the time. I believed it was possible, but I had no idea how we were going to make these foods. So we put together this great team of people who started by studying how meat works, and dairy and fish, but let's just focus on meat. How does meat work as biochemical system? So the things that people value from meat, particularly the sensory pleasures. So the nutrition and affordability is trivial. I mean, you know, you can get all the protein from that you would get from the, let's put it this way. The global soybean crop, which is grown on less than 1% of Earth's land, contains 160% as much protein as all the meat consumed globally, okay? So from a protein supply standpoint, trivial problem. The cost per gram of protein is less than 5%, the cost of the cheapest cut of meat and so forth. So affordability and nutritional value are not hard problems. The problem is nobody wants to eat soybeans. And so deliciousness and the flavors and aromas and the specific textures and mouthfeel and that whole sensory experience, that's what we need to figure out. But the thing that was obviously true is those are emergent properties of a system defined by biomolecules, proteins, fats, the kinds of small molecules that are found in cells and so forth. If we could understand how that system worked biochemically, I believed that we could source those molecules from much more sustainable sources than cows, and not only reproduce that desirable experience, but actually do a better job of it, because the cow is not even working on the problem anymore, and we can get better every day. So a key question for us is, why does meat taste like meat? This question had obviously never been answered before, because when we looked at it, it turned out the answer was easy to find and obvious. Therefore, no one had ever looked at it before, because they would have found it 100 years ago. And that is, it's the thing that makes it unlike anything from plants is a molecule called heme, which is the thing that makes your blood red. It carries oxygen in your blood. It's iron. It's the source of iron in meat and so forth. But it's also one of the best catalysts in nature. So this summarizes how it works. You could take a broth of amino acids, vitamins, fatty acids, sugars, basically vegetable broth. And if you cook it, you get something that's, maybe a little savory, not that interesting. Throw in heme, and it completely changes. And when you cook it, you get this explosion of flavor and aroma that are products of chemical reactions catalyzed by heme that turn these amino acids and vitamins and fats and sugars and so forth into hundreds of these diverse volatile compounds that make up the flavor and aroma profile of meat. Okay, so that was one discovery made. And it turns out it's not just true for beef, it's true for all kinds of meat, including actually fish as well, and so forth. So it turned out that actually a lot of the answer was simple. I'll just go through this one really quickly. It's just a random thing that I think is interesting. One of the compounds that's produced by these heme catalyzed reactions actually turns out to be the thing that makes blood taste like blood. Okay, it's the bloody odorant. And it's one of the most potent odorants that's ever been discovered. Your humans and pretty much all animals can detect these molecules at concentrations orders of magnitude lower than most volatile compounds can be detected. And they smell like blood. And it turns out that if you put those molecules on a piece of wood and put it in vicinity of a carnivore, they do this weird behavior where they just make a beeline for it and they put it in their mouths and they give it lots of love and they sleep next to it and so forth, as if it were the carcass of an animal, which makes me think that maybe when people say they crave meat, that there really may be some sort of a triggered innate behavior from this heme catalyzed product. Anyway, okay. Impossible has been in business now we've existed now for 10 years. We've only had products on the market for about 4 years. But the proof of concept, we're a long way from being done. But the proof of concept is it possible, the question is it possible to make meat without using animals that hardcore meat lovers like as much or more than the traditional meat from animals? And the answer is absolutely, overwhelmingly yes. We have the proof of concept. We now have 3 different kinds of meat from 3 different kinds of animals where we've done large consumer tests, which you prefer, A or B, where the consumers, a majority of the consumers have preferred our plant-based product over the animal-based product they've eaten all their lives. So this is totally doable. That's the point. We're not done, but this is clearly doable. And in the market, we get the same result. So our now that we're in retail, we know that 90% of the people who've ever bought our product are omnivores. They've eaten meat regularly before that. We also know that from a lot of consumer tests that 3 out of meat lovers don't love the fact that their meat is made from the corpse of a slaughtered animal. They just accept that as part of the price for something that they love to eat. They would actually prefer it to be made from plants, and that's sounds counterintuitive, but it's sort of like, of course, why would you value the way that it's made? We know that 70% of our consumers who have ever tried our product have become repeat customers, so it delivers for them, and more than 90% rate it 9 or 10 out of 10 on a satisfaction scale. So my point is, I'm not trying to give ourselves a pat on the back. I'm trying to make the much more important point. This is doable. It is possible to make meat that outperforms for current meat consumers the meat made from animals and make it from plants. Of course, it's vastly superior from an environmental standpoint. We've done now 3 life cycle analyses of our products, and this is typical. We use less than 4% of land, way less water, greenhouse gas and fertilizer. Last point here, people sometimes think, oh, 2035, yeah, maybe you can eventually do this, but 2035, no way. But there's been endless examples of better technology coming along, doing a better job of serving consumers and replacing an ancient, an old technology in a decade. And this was roughly true for horses replacing cars. It took less than 8 years for the digital, from the first digital camera to put the entire film industry out of business. So I think it's a realistic target. Okay, these are just now provocations because I know I'm now running over. I think there's a tremendous opportunity here for agricultural research, which I know is what the Danforth Center is all about. One thing is not just about the science of crops and stuff like that is, we intend to win in the marketplace and make it a losing proposition to be raising animals for food, to be using animals for food technology. We're not going to go out there and beat up on farmers and ranchers and so forth. This is red-blooded American capitalism, the free market at work. This is what we're trying to do, but we don't want it to be a bad outcome for the farmers and ranchers. That's, I mean, people don't feel like it's counterintuitive, but a quarter of the people at Impossible Foods have farmers and ranchers in their family that are, raising animals for food. We don't want to do them harm. And so here's a provocation, okay? They could be our best allies in reversing the historic damage from this industry. Because if it's you can't make money in that business anymore, how could you make money? They're the perfect people to be allies in restoring the land, in rebuilding the biomass on the land and the healthy ecosystems and so forth. Staying on the land, staying in their homes, continuing to support their communities and so forth. And from the amount of money it would cost if we said, well, this government will support this. It's way less than we spend on teachers. It's less than 2% what we spent on COVID relief last year would enable this. And it's just as important for the future as teaching, I would say. So this would be something to consider. Anyway, happy to throw that out for debate. From a more basic agricultural research, the basic problem that we have is that the crops that are grown at scale were not optimized at all for the kind of thing that we're trying to do. They're just like bulk nutrients to feed livestock, who very inefficiently turn them into food for humans. If you said, what we want are crops that provide the best ingredients for making delicious foods directly for humans, that's an entirely different specification and completely doable, and a huge opportunity for creativity by agronomists and plant scientists. So I would say that's another provocation. I won't talk about this. I'll just make a point that from food security standpoint, one of the best potential ingredient proteins for human food and for plant-based meat and stuff like that is a protein from leaves, because it would enable you to have a wide diversity of crops that could serve as a protein source instead of because the proteins in leaves are so evolutionarily conserved. And so we're very interested in that. Rubisco is the most abundant protein on planet Earth. It's a protein that's involved in photosynthesis, and it's about a third of the total protein content of every leaf on Earth. And it's got great functional properties as it happens. Okay, that's my provocation, and sorry to run over. Looking forward to talking to you, Stephanie, and I'm sorry.
Yes, Pat, no.
Wasn't watching the time.
No, it's fine. Thank you so much. I learned a lot, and I was really glad to see some of the acknowledgement on the farmer piece. I started my career with the National Cattlemen's Beef Association. That product is near and dear to my heart, but really so are the people who produce it. And so I'm really glad that you are wanting to bring them to the table, hopefully engage them as stakeholders and allies in this process. I do have a lot of questions I want to get to. So let's get to a couple of these. Pat, what do you think are the biggest limitations to adoption of plant-based meats and animal substitutes? Is it consumer preference, or are there other larger structural issues, maybe with the industry, the food industry or the agriculture industry, that you face?
Well, that's a really good question. I think both of them are I don't think of them as obstacles. I think of them as speed bumps, basically. Because I think, again, a whole history of economics has shown that if you can make a product that does a better job of delivering what consumers want from a product that they're currently consuming, it's just a matter of time. But yeah, so one of the problems that we face is that every plant-based product that has claimed to be a replacement for meat before ours is terrible. Okay. And I mean, for meat eaters, I mean, I don't even like them. I haven't eaten meat for 45 years, but I never liked veggie burgers or any of those products. And I don't even like tofu, actually. So, I get it. They're not good. And I used to like meat back when I ate meat. So, you have to be dead serious about delivering uncompromising deliciousness to do this. And no one's done that before. And so at this point, our household penetration, even though, we're doing really, really well in terms of growth and stuff like that. Only 3% of households in America have ever tried our product. Okay, so the level of awareness is, among my friends, it's very high, but in the real world, it's not so high. And the people, if you were to just say, oh, this is a plant-based product, they would just say, oh, great, yeah, another nasty veggie burger that I'm never going to put in my mouth. So we have to get over that hurdle of very negative expectations and get people to try it. But as I said when I was giving my talk, 70% of the people who've ever tried it become repeat customers, okay? And it displaces the animal product in their grocery basket. And we know that from retail receipt data and so forth, that they're not replacing a veggie burger with an Impossible Burger. They're replacing the animal derived meat with an Impossible Burger, which is exactly the intended thing. But we just have a long way to go in kind of raising awareness, getting people to try it. And that's one thing. The other thing is that, frankly, and the food industry, and really the food industry broadly defined, including the supporting agriculture industry, it seems to be almost devoid of curiosity and innovation. And I mean, the classic example is, if anyone had just decided, didn't have to be me, I'm going to figure out how meat works and how meat makes its flavors and why doesn't behave like broccoli when you cook it. They could easily have figured it out if they were just basically competent at biochemistry. And in all of history, no one even bothered to try. I know they didn't bother to try because if they tried, they would have figured it out. So that to me is so weird, being a scientist, but it's also a problem for us because that industry expects things to be the same year after year after year, maybe a tweak or something like that. And we're trying to do something, fast and disruptive. And we're, more and more realizing that, okay, we can't rely on other people to do parts of the work for us. We're just going to have to take over more and more of that supply chain, so that we're not dependent on other people who just,
Let's talk about the consumer. Let's talk about the consumer just a little bit more. We've got time for maybe one or two more questions. So consumer affordability is and equity, honestly. So can the everyday consumer afford this? Can low income consumers afford this?
Great question. And it's extremely important to me because one of the things, I used to be a pediatrician and I'm aware of the fact that, most of the people who are food insecure and are suffering from malnutrition and starvation are kids. And most of them live in the poor countries of the world. And the biggest two nutritional deficiencies are protein malnutrition and iron deficiency, which are two things that we can contribute to solving. And the only way it'll work is if we can make products that are vastly more affordable than the animal products. Otherwise, it doesn't do them any good. Well, fortunately, the economics are vastly advantageous for us because think of all the things that cost money in agriculture. Land, either you have to just manage the land or you rent the land or whatever. Land, water, fertilizer, pesticides, labor. Our process requires a lot less of all of those. So 1/25 the land to produce ground beef our way, about 1/10 the water, less than 1/12 the fertilizer and pesticides. We turn those plants and plant proteins into our product proteins with a 1-to-1 efficiency, okay? That means we need to grow much less soybeans. People think, oh, you're just gonna have to grow more soybeans. No, we're growing, the soy protein on Earth is 60% greater than the total protein all the meat consumed on Earth. You need less, okay, plant crops. And you need zero labor to manage the animals, okay? So all the economic drivers that add up to the cost of producing meat from animals are vastly advantageous for us. The problem is we don't already have all the infrastructure in place, and we're building it for the first time.
Yep.
And we don't have the economies of scale because the way we're growing, we have to build capacity in anticipation of our growth. And so we're always kind of growing into it. So there's just a bunch of things that have to do with the fact, not the structural economics of how we're doing things. It has to do with when you're a fast growing startup, you know, you don't have the kind of optimized economics of a mature company, but it's absolutely there. And there's stuff that I can't even talk about that's confidential about our current operations, but I can just tell you, there's no question whatsoever that we will be able to sell our products way less expensively than the incumbent industry when we're, you know, at scale, and even well before we're fully at scale.
Okay.
And that's really important. I totally agree with you. Making food affordable for people, that's such an important goal.
Right. That's exactly right. Pat, we could talk for hours. This was fascinating. I'm sure our audience enjoyed it very much, and we certainly appreciate it, but we're going to close out for now. And with that, I just want to say we are so grateful to all of you for being here tonight, particularly those of us joining for the first time. In just a few moments, you will receive a brief email survey. We would greatly appreciate any comments or suggestions you have regarding tonight's event. If you would like to learn more about the work of the Danforth Center and our upcoming events, please visit the website danforthcenter.org. And if you are so inspired, I encourage you to join us in advancing the center's mission with your contribution of financial support as well. Have a wonderful evening.
Thanks, Stephanie.
Thanks, Pat.